Thanks, Matt, for the introduction. So indeed, I'm Sofie. I'm a freelancer in machine learning and natural language processing at my own company, Oxycoded. But the work that I'm presenting today is what I've been working on the last few months in close collaboration with Matt and Ines on providing a new module into spaCy about entity linking. So what is entity linking? Some of you might be familiar with this graph from spaCy, where we see the whole pipeline that spaCy does, coming in a text on the left, and basically then running all sorts of algorithms to produce a structured document on the right. But currently, this pipeline works purely on the text itself, right? So it looks at the input text, it looks at words and sentences, at the syntax, and indeed even at the dependency parse, even if almost nobody uses it. And then it tries to extract all of this lexical information. But how can we then ground that information into, let's say, the real-world entities, or at least an approximation of it being a knowledge base, such as, for instance, Wikipedia? So let me give you some examples of entity links. We have a text here about a certain Lord Byron and a Lady Byron who gave birth to a girl together, and she was called Ada. So there's a lot of Byrons in this text, and you see here the output of spaCy's named entity recognition. So you see that there's a lot of person entities being recognized. But now the question is, who are all these Byrons, right? And so that's the topic of this talk today, trying to link those entities, those persons or organizations, locations, to an actual identity in a knowledge base. So specifically, if we would look at Wikipedia, we would find Lord and Lady Byron on the right, and their child, Ada Lovelace, on the left. And as you can see from this simple example, there's a lot of synonymy. I'm sure most of you know Ada as Ada Lovelace, which was the name that came from being the Countess of Lovelace, but she was born as Augusta Byron. Later on, she was also called Ada King, so you can see that even the surname, the first name and the surname can differ. There's a lot of polysemy, of course. A lot of people are called the same, so it's difficult just from the lexical text or lexical clues to find out which person is which. So I'm sure you'll agree with me that context is everything for this particular challenge. So let's just do some warm-up examples. Feel free to shout out if you know the answer. So we have here a Russ Cochran whose reprints include a certain library in black and white. So is this Russ Cochran an American golfer, or is he a publisher? Publisher, thank you. Second example, he felt that Rose and the doctor's developing relationship was not subtle. So is Rose an English footballer, or is he or she a character from the TV series Doctor Who? Character, Doctor Who, indeed. And the final one, this happened to DeLorean owner Johnny Carson shortly after he was presented with the vehicle. So is Johnny Carson an American talk show host, or is he an American football player? Both, indeed, right. So that means that you don't know, right? I mean, it's just too ambiguous from the sentence alone to be disambiguating this. And when I actually encountered this example in the training data set, I went through the Wikipedia article, and it took me like 3 paragraphs before that to actually find the information, which of the two it was. I will keep the answer secret. So I want to talk to you about how we want to implement named entity linking into spaCy. This is very much a work in progress. If any of you have been working on this task, you will appreciate that it's quite challenging, and from the examples we saw as well. But I want to present you what we've been doing so far, and I hope that if you have any feedback, please come and find me or Matt or Ines or anybody else from the Explosion team to discuss. So when we started this, looks to be end of February that we started this, we did do a shout out to the community to ask what people would be expecting of this functionality if we would have it in spaCy. So a few things came out. The fact that we don't just want to support English, but really do cross-lingual mapping. Wikipedia was also mentioned not to be the ideal knowledge base, but rather Wikidata, and I'll explain a little bit why in the next slide. We want to be able to train custom relationships or use your own knowledge base, so you don't want to be defined by the knowledge base that we use at spaCy, which I think makes a lot of sense. We just want to have a use case that works and then allow you to do your own thing, as with most algorithms in spaCy. And finally, we also came across spaCy, which has been developed recently around the biomedical domain. And it's really a perfect way to see what they have been doing, whether it fits into the interfaces that we have been developing at spaCy. And coincidentally, Mark will be talking about spaCy in a few talks from now, so that's perfect timing. So from that community feedback, we distilled a few design principles. So as I said, for a first prototype, we will be focusing on Wikidata. I'm saying instead of Wikipedia, it's more sort of on top of Wikipedia, so because we will also be using some data from Wikipedia. The main advantage being that then we'll have stable IDs, there's a higher coverage, and also better support for cross-lingual mapping once we go further than just English. We also want to have a canonical knowledge base with potentially language-specific feature vectors, but I won't be talking about that much in this slide. And we want to do the KB, so the knowledge base reconciliation once, as sort of offline data-dependent step. And of course, as with everything in spaCy, it needs to be production ready, so it needs to be fast, preferably keep the knowledge base in memory and have it easy to use. All right, so let's dive right in. So by processing a full dump of Wikipedia, we basically get all of these intra-wiki links. So you see there, the sentence is about Ada again. She married William King in 1835. So you see the intra-wiki link where you can easily parse the fact that the William King mentioned there is linked to that longer entity, William King Noel, 1st Earl of Lovelace, who is a very specific person who has a very specific Wikipedia title page. So we can get all of these aliases and their prior probabilities, how likely it is that a certain alias links to that entity. We can get those for free by parsing Wikipedia. So that's what we did. And then we also parsed Wikidata, which is another huge dump of data. And what we got there mainly is the links between those Wikipedia pages. You can see on the right that, for instance, this one has one in German, English, and Finnish, I guess. So we get there the links to the Wikipedia pages, but also the descriptions. There's a very short description there talking about William King, saying that he's an English nobleman, and so on. And we found that these descriptions are very concise, very informative, so we are going to use them as sort of disambiguation information in the entity linking model. So once that we have all of those entity descriptions, we basically use the pre-trained word embeddings that we get from a large spaCy model, and we run them through a simple encoder-decoder that will just allow us to get these entity descriptions in a fixed size, in this case 64 dimensions, vector. So once we've trained this encoder-decoder, we decouple the decoder, we just keep those encoded descriptions, and we keep them in the knowledge base so that we can do this step basically offline once. And I just want to pay a little bit of attention as well to the fact that we had to do some pruning of this knowledge base just to be able to keep it in memory. I won't go through these parameters, they're also adjustable, but basically what happens here is that we keep about 1 million entities of the total of 8 million that we parsed out. If we write this to file, it's about 55 megabytes, so it's not too bad for 1 million entities and 1.5 million aliases. If we also store the entity vectors, it becomes quite a bit larger, of course, but still it's written to file, read back in a matter of seconds, so I think that's nice. Then the general flow is once we have that knowledge base built, basically that will also expose some functionality for candidate generation. So what happens there is you get your alias or your mention from text, such as Byron, and then you want to output a list of candidates. For instance, you want to output Lady Byron, Lord Byron, Ada Byron, all of the possible candidates. And then on top of that, we want to implement the entity linker who picks the right one from that list of candidates. So it's sort of a two-step procedure. So the entity linker then looks like this. Let's work from the bottom up. So on the left, we have the candidates, we have the entities. Like I said, so for each entity, we have some information from the knowledge base. We have a prior probability of the fact that how likely it is that this entity is linked to that specific mention. This is just a floating point number. And then also from the KB, as I explained before, we have this entity description, which is encoded, in this case, in a 64-dimensional vector. And then on the top, we have our NER mention, which is where we want to look at the context. So from the preceding NER algorithm that we've run in the spaCy pipeline, we can get a type. In this case, using this large model, we have 16 different NER types, so we just encode it with a one-hot encoding, so that results in a 16D vector. And then we also have what we call a sentence or context encoder. Right now, this is just a CNN with an output of about 128 of a dimension of 128. This is configurable, and also we'll be looking at different models like STMs as well in the future. But for now, this is just to test the framework and see whether it runs. So once we have that feature vector, we'll actually run the entity linking model on top of that to get a probability of the fact that that entity is the correct match for that mention in the sentence. And so for the training, obviously we can use that to calculate the loss function, compare it with the gold label, which is just a 0 or a 1, and then continue training. All right, so how am I doing on time? Pretty good. So I want to show you a little bit of code just to give you a little bit of a feeling how this now looks like in spaCy. So as I said, the knowledge base is being constructed beforehand. So here is just a very simple example. Of course, you want to do this in code with a proper data set, but I just want to have some stupid examples. So first you will add all of your entities, and you see those Q identifiers are like real Wikidata Q identifiers. So you add all of those entities first, and you add their entity vectors as well, which were pre-trained. And then once you have all of those entities, you will basically add the aliases. So this means, for instance, if we have the word Douglas, we will say, okay, Douglas can refer to those 3 different entities with 3 different probabilities. And those probabilities are normalized to the length of the candidate list. So those need to sum up to 1 or be a little bit less than 1, but they cannot exceed 1. Because that's basically the prior probabilities. If you look at, for instance, a longer string, such as Douglas Adams, this might only link to 1 specific entity, so maybe the probability is much higher there to link it. So this is how you build your knowledge base. Then once you have the knowledge base, for those familiar with spaCy and building pipelines or custom pipelines in spaCy, this will look quite familiar. So you basically just create a new pipe, which is called entity linker, and there you can do some configuration as well. You add that, you add the knowledge base to the pipe, and you add the pipe to the NLP object, and you're basically good to go. Then you can start training it. So at this point, you will disable all of the other components because you don't, at this point, we've basically decoupled the named entity recognition and the linker. So that means that we won't be training them together. This is something that we can think about for future work, for sure. But right now, it's sort of a waterfall processing pipeline. So we disable all the other pipes, and we start training the entity linker as you would just with NLP begin training and then update. Once you've done all the training, you basically enable all the other pipes again, and you can just run your text through NLP as you would to obtain a document, and then basically the annotations will be available by going through the doc.ends and finding this KB_ID attribute, which is new and which holds the Q identifier, which then gives you sort of an entry point into the knowledge base if you want to retrieve more information about this entity. So I want to quickly show you also some accuracy numbers, keeping in mind that this is a little bit of work in progress. So we've done some training on the Wikipedia mentions that we extracted from the text. The specific experiment is run on 200,000 mentions, which is not too many. I mean, we could definitely train it longer. And the knowledge base is the same one that I showed earlier, which has about 1 million entities. And it's good to keep in mind that that's only about 14% of all of the entities that we originally parsed out. So it's quite a small set of it. If you look all the way at the right, the last column in this table, we see here that the maximum accuracy that we can obtain with this knowledge base, it being pruned quite heavily, is 84.2%. So it's definitely not 100. It's also, I think, a reasonable trade-off, keeping 14% of the entities still being able to get 84% accuracy, but it's also definitely a limitation. So you can play with those numbers to have a higher, to have a larger KB. Then on the other spectrum, if we would run a random baseline, so that means that we would just take the candidates offered by the knowledge base and we would pick a random one from the list, then we would obtain about 54% in accuracy. So not too great, obviously. If we look at the context encoder by itself, so this is the one that's looking at the sentence and trying to find lexical clues to disambiguate which of the entities is the correct one, then we get to about almost 74%. But which looks great because it's quite a bit higher than the random baseline, right? But there's a stronger baseline here, which is actually just taking the one with the highest probability. So if you would say, for instance, Douglas is almost always Douglas Adams, then we'll just pick Douglas Adams no matter what the context. So that's the prior probability baseline, and it's quite high, as it usually is. And it's also a little bit because of how the data set is constructed and biased. I'll talk about that a little bit later. But so in this case, it's 78.2%. So you would say, well, that's not too great because not using context is actually worse, is actually better than using context. But if you would combine the two, you do see that there's a small improvement. I would call it a marginal improvement right now, but at least it's consistent. So throughout the experiments that we've done, we did see that if we add the context encoder on top of the prior probabilities, it does improve slightly. So that's pretty much the same conclusions. So on the previous slide, the data point that I showed you is the one completely on the right in this graph. So that's about 74% for the context encoder in blue, and you see, the green prior combination, prior probability, baseline at almost at 79%, I thought it was. What you do see here is that if you keep training with more entities, that it does improve slightly, but it doesn't. So beyond the 200,000, it doesn't seem to be improving quite as fast. But at least it seems to be picking up on something in the context. So that's at least encouraging results. Then I also wanted to go through a little bit of an error analysis, because having these results, I think the first question that obviously comes to mind is, so what's happening in the data, right? What's happening in the predictions, and why are we seeing these kind of performance numbers? So this is one example sentence that I didn't exclude any words or so. It's just an enumeration of places in Cambodia. So we have there Battambang, which was predicted to be city in Cambodia. It should have been province in Cambodia. So it's quite clear that this would have been difficult for the entity linking model either way. This is always a problem, especially with these cities that are the capitals of specific provinces. I mean, if I tell you that I live in Antwerp, you might make the inference that I live in the city of Antwerp, but I might as well be saying that I live in the province of Antwerp. So it's ambiguous either way. This case is where it talks about societies in the ancient civilizations of Greece and Rome that preferred small families. So in this case, what the entity linker does for the span Greece is it predicts the actual country Greece as we have today, instead of the more accurate entity ancient Greece. So there's no excuses here. I mean, even the word ancient is specifically in the sentence, so it should have definitely gotten that right. Then there's another one here, which again talks about Asian civilizations. I didn't cherry pick these ones. These are just the first ones that rolled out of my screen. So this Roman, Byzantine, Greek origin are amongst the most popular ancient coins collected. So here, the entity linker does predict ancient Rome, and it should have predicted Roman currency. So it's a little bit unfortunate. It started to get it a little bit more right, but there was an even more accurate entity, being the Roman currency. I looked at it in the Wikidata entry, and it turns out that this Roman currency doesn't have a description in Wikidata. So that's definitely a flaw of the system, that it has no way of accessing additional information. So that's definitely something that we'll be improving and adding more features into the linking model so that it can recover from this. And then finally, this was one of the first examples that I encountered, was this Agnes Maria, who was a queen of France, and she died in 1200. So what the entity linker does here, it predicts this entity called Kingdom in Western Europe from 1980 to 1700 and so on, which sounds pretty accurate to me. Even the date is in that interval. But the gold data says that it should have been Republic with mainland in Europe and so on, which is the actual France of today. So in my honest opinion, I know I'm always biased and defending my machine learning models, but in my honest opinion, the gold was incorrect here and the model was correct. So I think it's clear from these discussions and from some further analysis that we did, is that there's something going on with the data. So that's one of the first points of future work that we want to address. As Matt puts it so eloquently, we need to define a hill worth climbing, right? So we need to obtain a better data set that is not automatically created and biased. Unfortunately, we have access to a great annotator tool, Prodigy, so we can definitely work with that. And only then, once we have a more robust data set, we can actually go back and improve the models, tune the parameters, and look at different architectures and so on. The other thing is, it's sort of related to the first point, is that we want to add in coreference resolution, because the entity linking challenge is very much related to being able to understand those coreference chains in text. So if a certain entity refers to an entity that was mentioned before in another sentence, we need to be able to find that link, and that will also help us improve document consistency of the predictions. One other thing that I already mentioned is adding more features into the entity linker. So there's definitely a lot more data at Wikidata that we can exploit, like the knowledge graph. There's some prior work on this, and the Wikidata dataset is really cool to parse. So definitely something to look further into. And then finally, obviously, as I said on one of the first slides, we also want to be able to go beyond Wikipedia and Wikidata. And the challenges there will be to provide or to make reliable estimates for this candidate generation step, because you need estimates for those prior probabilities. And I think Mark, in his talk, will be talking a little bit about that as well for spaCy and how they solve that in the biomedical domain. Okay. Thank you.